2.1, angles in standard position. So this unit's called trig, and we're going to do trig ratios of different angles. Whoops. So what happens is we're now taking angles and we're putting them on the xy plane, on the Cartesian plane. So an angle is said to be in standard position when the vertex of the angle is located here. So remember, the vertex is here's where it starts, here's where it ends, it's vertex of the angle. And so it's in standard if we put it right on the Cartesian plane. So we used to just say, oh look, here's an angle. This is called the initial, this is called the terminal. Now what we're doing is we put it on the Cartesian plane, and we always put the initial here, and then the terminal can be wherever. The initial arm always lies right here. So we can take this angle here, and let's say it's 45, then we put it on the Cartesian plane, we put the initial arm here, and then it goes to 45. And that's going to help us because we're going to learn information about where that arm lies. That's why we do that. Okay, so that's new. We never mixed up Cartesian planes and angles before. We always measure the angle in a counterclockwise direction from the initial to the terminal. The quadrants of the Cartesian plane are labeled with Roman numerals, also in a counterclockwise, beginning from the positive. Okay, and on the side of the classroom, it shows where the quadrants are. We start with number 1, and it's from 0 to 90. We're going counterclockwise. Then we go from 180, from 90 to 180. Then from 180 to 270, we're just keep adding 90, and then from 270 to 360. All angles in standard position have a corresponding acute. Remember, it's acute if it's less than 90 angle, called the reference angle. The reference angle is the acute angle formed between the terminal arm and the x-axis. So this one here, this is the angle. This is remember, my initial arm here to terminal arm. The reference angle comes up to the nearest x-axis. So if I had a angle that looked like this, initial and terminal arm, its reference angle will go down to the nearest x. That would be its reference angle. Okay? Similarly, if I had an angle that looks like this, so here's my initial, here's my terminal arm, this is the angle, its reference angle would go up to the nearest x-axis. Okay? So I think I've done just about all the cases there. There are two special right triangles for which you can determine the exact values of prime trig ratios. Okay? And this is something that we need to memorize, and I'm going to spend some time doing question number 5 with you. I know it's not assigned. Okay, we use a special 45-45 triangle. Each side is 1. So sine of 45, remember SOHCAHTOA, is opposite over hypotenuse. Opposite is 1, hypotenuse is 2. 1 over root 2. Cos of 45 is adjacent, which is 1 over hypotenuse, root 2. And tangent is opposite over adjacent, 1 over 1. Okay, this is the special triangle we use for 30 and 60. Okay, notice a couple things. 60 is or actually 90 is the biggest angle, and the biggest side is 2. Okay, I'm just going to get a calculator to show you that. Is that going to get me a calculator? Did that work? There we go. Okay, because the square root of 3, if we do the square root of 3 just to show you what value that is, I cannot find a square root button to save my life at the moment. There we go. 3 square root is 1.7. So this is small. This is just 1.7. I hate when my smartboard does that. So this is about 1.7. Okay, so the next biggest side is 1.7, and the next biggest angle is 60. So look, and then 30 is smallest, and the smallest side is directly across from that. That's a relationship you should know in triangles, that the biggest angle is across from the biggest, the second biggest angle is across from the second biggest side, and the smallest is across from the smallest. That will help you remember this triangle when you set it up. Okay? The other thing, so sine of 30, they took 30. Sine is opposite over adjacent, and they did the same thing here. 60, so we look at 60 opposite over adjacent. 3, sorry, opposite over hypotenuse is root 3 over 2. Okay, so these, whenever I say the exact value, cos of 30, if you put that in your calculator, you're going to get decimals. The exact value is square root 3 over 2. So it's going to be questions that come up where they say, what is the exact value of cos 30? Okay? I just want to do a couple examples with you. Determine the reference angle for each angle. Sketch it in standard position and label the reference. So standard position means we're going to start right here. Oh, come on, pen. Means we're going to start right here. So this one says, the first one is 315 degrees. So in the first quadrant, I only go up to 90, then 180, then 270. So 315 is going to be somewhere here. And don't worry so much about drawing it exact. So 315. So its reference angle is then going to be right here. This is its reference angle. So to find its reference angle, it looks like its reference angle is 360 degrees minus 315 degrees. Okay? So 360 minus 15, 315 rather. That looks like that's going to be 45 degrees. So its reference angle is 45. And so reference angles are important because we know exact values of the trig ratios for 45. So that's why we need to know reference angles, because then we can use these exact values. Okay, let's try another one, 201 degrees. So remember, this is 180, so 201 is going to be somewhere here. So its reference angle is going to be right there. So let's think about it. We have 180 degrees here. So it's whatever's left after 180. So we're going to take 210, we're going to subtract 180 because I don't want all of this stuff. I only want what's left. So 210 minus 180 is 30. So its reference angle is 30. Okay, and I just want to spend a second looking at this working example number 4. So we have an 8-meter boom used to move a bundle of piping from point A to point B. So from A to B. From A to B. It's 8 meters long. Determine the exact displacement to the end of the boom when the operator raises it from 30 to 60 degrees. So first of all, we're finding the distance A. So they said, looking at just this triangle here, we know that the cos of 30 is equal to the adjacent over hypotenuse. So adjacent is A, what they're trying to find out. Hypotenuse is 8. And then they got this root 3 over 2. And where they got that from is they had memorized cos 30. You guys actually won't have to memorize because you can always bring something in. But the cos of 30 is root 3 over 2. So they took that information, see if I can get to the right page, and they put it here. Then they cross multiplied. 2a is equal to 8 root 3, and they found the exact distance of a. So leave your root 3's, don't put it in a decimal. Treat it just like a variable. It stays as itself. Okay? Now they're looking at distance b. This distance. So now we're looking at this triangle here. In this triangle here, we still have 8-meter boom, but this is 60 degrees. So now they want to know b. Write the appropriate ratio to solve for b. So this b is still adjacent to 60. So we're going to go cos of 60 is equal to ca adjacent over hypotenuse. So it's going to be adjacent is b and the hypotenuse is 8. Now we know cos of 60 from our exact values. Okay, and cos of 60 is 1/2. So we're going to sub in that 1/2. So we know that 1/2 equals b over 8. Solving for b, we get 8 equals 2b, or not 2b, and b equals 4. So the distance is 4. So b is 4. So here we have 4 root 3, and this distance here is just 4. So how much has it moved? We're going to subtract them. Okay? So we're going to go 4 root 3 minus 4, okay? And I would accept this answer as is. They say, because we can't combine that. We have 4 root 3's minus 4. We have 4 apples minus 4. We can't combine those things. But they say if you take your calculator and you go 4 root 3 minus 4, you would get approximately 2.93. So if you go 4 times square root, oops, that's not what I wanted to do. So order of operations, you have to figure out how. I would probably do this, 3 square root times 4, and then I would subtract 4 from it. That's my order of operations. 2.98, 2.93, 2.928. Yes, that's correct. Okay, so using exact values will help us solve problems.